Hi there, VENLAB kindly sent me another multimeter for review. It's the VM-200M. I'm not paid for the video, but since I'm allowed to keep the meter, I marked this video as promotion. From previous reviews, you know that doesn't stop me from sharing all my findings with you. In the box are a pair of AA batteries, test leads, the meter, and the user manual. Let's have a closer look at the meter. After all the smart meters lately, it's refreshingly manual, yet apparently true RMS. Sadly, only a 200 volts and 600 volts AC volt range and no AC currents. But DC wise, the ranges go from 200 millivolts to 600 volts and 200 microamps to 10 amps. Resistor, diode and continuity, and the usual transistor test socket. And speaking of sockets, the milliamp socket shares the same socket as volts and ohms. That's an accident waiting to happen. I also would not trust the Cat2 600 volt rating, especially because of that transistor test socket. This socket and electrical safety just don't go together, because something might still be plugged in there, easily touchable, when probing mains voltage, which would be very risky. If you have a meter with that test socket, always make sure it's completely empty when measuring high voltages and never put your fingers or hand close by or on top of it. With that out of the way, the door to the battery compartment is held with a single self-tapper. No metal inserts here. The leads are plastic and relatively short, from plug to tip 90 centimeters or about 3 feet. No markings on the cable. The relative long probe tips have removable covers that expose only the very top. This is good. While working at the probes, I might as well test continuity. Not great, at least the beep is relatively soft. I did the same test with Pomona probes and it was pretty much the same story. The other function of this range is to test diodes. No problem with a single diode, or 2 in series. A red LED also works, but not 2 in series. A yellow LED works, but a white LED does not. Since my surprise finding that some smart meters like the TM150 have a rather low input impedance, I now test for that, even though this isn't a smart meter. Measuring 1 volt, it draws 0.1 microamp. That calculates to 10 megohm, which is absolutely fine. And 0.1 volts in the 200 millivolt range is at the limit of low currents of the BM869S, but with the values shown, that's still 5 megohm and no problem. In all my reviews I have looked at the DC plus AC behavior. You might think with the lowest AC range of 200 volts that would not be an issue in the VM-200M, but not so. Here's a 12 volt AC voltage with a 200 millivolt DC component and the 2 volt DC range is not happy at all. Selecting the 20 volt range at least gets rid of the overflows, but it's still not a stable display. Increasing the DC component shows that it tries to measure DC correctly. The higher the DC voltage part and the lower the AC part, the more stable the display becomes, but with many more sophisticated multimeters, mixed AC plus DC is a situation best avoided with the VM-200M. It's been a long time since I used a meter with one of these transistor test sockets. Anyway, I plugged in an NPN BC107B into it and selected HFE, which measures the current amplification or gain of the transistor. 384 apparently, but absolute values are questionable because the transistors are not very linear and the gain varies a lot depending on how it was measured. So this test serves more as an okay or dead type of thing. Using the same transistor with my component tester, and it says the HFE is 214. The datasheet says depending on collector current it can be from 150 to 460. Even using this as a go-no-go test is not easy. This is a bad germanium NPN transistor. The only clue is that the HFE is way higher than you would expect. While the component tester correctly reports a short between collector and emitter. Since we are at electronics, let's have a look inside the VM-200M. 3 screws need to be removed. And the very thin rubber-like skin that partially covers the meter. Not too much going on here. everything is again handled by a blob, and there seems a programming port of sorts at the bottom for calibration in the factory. That round thing up there on the right is the beeper. The shunt for the 10 amp range is an SMD of 5 milliohms that will have to dissipate 0.5 watts. Although the manual doesn't mention it at all, I would limit the duration of such high current measurements and give some time for the resistor to cool down before doing the next. And speaking of current, interestingly, the 200 milliamp fuse is actually a resettable polyfuse, a PPTC, which is like a PTC going high resistance when the max current is exceeded and resetting once the current is removed and the fuse cools down. No doubt for normal electronics, where you actually run maybe an amp through the meter at 200 milliamp setting, that's not a bad solution. But when accidentally poking your probes into a switchboard with a meter set to 200 milliamps, I'm not so sure how well that will work. As for the other protection measures, there are 2 PTCs, a big fat diode, and resistors in a chain to improve their voltage rating. All in all, better than what I expected, and I've seen far worse in meters of this level. Sadly, as it's all too common these days, the 10 amp protection is a simple glass fuse without any higher object capability. I wanted to know more about the PPTC fuse, but could not find any suitable datasheet. This here is the best I could unearth. Clearly, this is not the one in the VM-200M. For a start, these look very differently, but I decided to have a closer look, expecting my GR265-200 to be maybe similar, although on closer inspection, hopefully not. Notice that the blurb states suitable for 260 volts AC, but the Umax shows 260 volts DC. 265 volts AC is more than 370 volts DC peak voltage. Further, the two 200 models have a holding current of 200 milliamps and trip at 400 milliamps. A bit worrying is that the max current they can handle without damage is just 3 amps, and it may take 9 seconds to trip at 1 amp. I decided to run a test. The same current of slightly more than 100 milliamp is going through the BM869S and the VM-200M. The VM-200M is in the 200 milliamp range. I'm recording the BM869S readings on my PC. When I increase the current limit of my power supply to 1.1 amps, the VM-200M overloads as expected, and after a moment the current slowly decreases as the PPTC heats up. After a while the current drops below 200 milliamps and the VM-200M starts measuring again. Of course, the overload still exists, so that it seems to work, and the low current shown is a bit misleading if you missed the overload condition earlier. At this moment I reduce the current back to the original 100 milliamps. The meter takes a bit to recover because the PPTC needs to cool down first before the current resumes its original value. The recording of the BM869S shows that it took 1.5 seconds during which the VM-200M was exposed to the full overload current. Then the PPTC started to limit the current progressively, and over the next 8.4 seconds it dropped below the 200 milliamp threshold, so the meter wasn't overloaded anymore. The datasheet we looked at earlier was not far off. While the PPTC responded after just 1.5 seconds, it took a total of 9.9 seconds for the current to be reduced below the 200 milliamp mark. I'm not quite sure what to make of this. On one hand, it's very nice that the meter survives this kind of lab accidents without costing a fuse. These overloads happen, and I have done it myself. But I doubt that this protection will save the meter when more energy is involved. Say you probe mains voltage with the meter set to 200 milliamp. The worry is that the PPTC will simply explode and the arc and fragments could injure the user or start a fire. By the way, the same is true for the simple glass fuse on the 10 amp range. If the meter is used for electronics, everything will be fine, but I would recommend to stay away from any high voltage transients or measuring high energy electrical installations. Let me know in the comments what you think about using PPTCs instead of fuses for meters that might be used to measure mains voltage. Because the VM-200M shares the milliamp current socket with the volts and ohms range, it is quite vulnerable to accidents. Say you are under 600 volts AC range to measure 115 volts mains. Since I don't want to destroy the meter, I reduce this to 1/10 of the voltage and limit the current in this demonstration. Seeing the result is just 110 volts, I want to change to the 200 volts AC range, but accidentally turned the range switch one notch too far, and now I am in the DC 200 microamp range. Oops! A large current of 0.37 amps AC flows through the meter. The PPTC can handle this. After turning the knob one notch back, it shows the voltage and the current is back to 0. The meter survived, including the 200 microamp range, which I tested off camera, but if this were a much higher AC voltage with lots of amps behind it, I somehow have my doubts. Back to tiny currents. The normal power consumption of this meter is very good, only about 1.4 milliamps. With good AA batteries, that should mean a battery life of around 200 hours or more. Backlight increases the current to 4.2 milliamps, still no issue. The beeper is usually the most current consuming device, so setting it to continuity and shortening the volts ohms with COM, and yes, it takes 23 milliamps for beeping. Testing when the low battery indicator comes on and whether the meter continues to measure the 10K resistor, shown as 9.97K, correctly as the supply voltage drops below the nominal 3 volts. At just below 2.4 volts the low bat symbol appears. That's not great, because 2.4 volts is the nominal voltage of 2 rechargeable batteries. If you use those, you would probably have used less than a quarter of the actual charge, but thanks to the low current consumption, even rechargeables will allow quite a number of hours before that point is reached. Continuing further and beyond 2.1 volts, the readout starts to change, getting pretty seriously wrong at 1.7 volts, and the meter shuts down at just below 1.6 volts. The manual doesn't mention it, but the meter shuts down automatically after 15 minutes of inactivity. There is a warning beep at 14 minutes, which I missed to record. By the way, you can disable the automatic power off by holding the light button when turning the meter on. Again, something the manual doesn't say. But as common with lots of meters, you still get warning beeps even if the power off is disabled. Anyway, if APO is not disabled, the meter turns off after 15 minutes and goes to sleep. Sleep current is around 23 microamps, about 1/50th of the operational current. Not a lot. 2 days of sleep is equal to 1 hour of operation, but it still drains the battery eventually. A quick run through the specs. DC volts accuracy is specified as ± 0.5%, indicated by the red lines, and it meets this easily. The large deviation at the beginning is misleading and pretty irrelevant in reality, and those small voltages, just one least significant digit difference from the correct value, creates a large error percentage. Within the most important range of 0.2 to 20 volts, the meter is amazingly accurate. And similar, the DC amps. Here the VM-200M has a slightly strange specification, varying between 1, 3, 1.5 and back to 3%, but has no problem meeting it. Accuracy and resolution for currents greater than 200 mA is reduced in that the next higher range is already 10 amps. Apart from this, I have no complaints, and especially from 10 to 200 microamp, the meter was again extremely accurate. Sadly, there are only 2 ranges for AC volts, 200 volts and 600 volts, both rated at 2% and amazingly true RMS. The drop at the low end is again mainly a problem of the lack of resolution. Having only a 200 volt range is not great when trying to measure less than 10 volts. It works, but you only get 1 digit after the decimal point. A bit pointless maybe, given the 200 volt range, but here's the bandwidth measured at a whopping 100 volts AC, or plus 40 dB. As it's common, the readout starts to drop shortly after 1 kHz, and the 3 dB point is just above 4 kHz. And last not least, the resistance range. It meets its 0.8% and 1% spec, except again at the very low end, for the reasons I've already mentioned. A bit disappointing is that the highest resistance is only 2 megohm, but I guess they ran out of range switch positions. The viewing angle is okay. I tried it in various places on the bench, lying and standing, and found no issues. The tilting bail isn't great and the meter slides quite a bit around when using the selector, but it still works. And that's my review of the VM-200M. I want to thank VENLAB for sending it in because I found testing the PPTC fuse quite interesting. Should you buy it? In my opinion, the fuses and the transistor test socket rules it out for any safe mains electrical work, but for car repair or bench electronics work is actually not bad. The accuracy is generally good and the only shortcomings are that the AC volts has no lower range than 200 volts and the lack of any AC current ranges. Battery life is good and the resettable fuse in the milliamp range will be appreciated by many. If you like my videos, don't forget to subscribe. There are more repairs and reviews coming up, and it would be great if you decide becoming a Patreon. That would really help the channel. As Patreon you always get early access to videos, a blog and other exclusive content. Thanks for watching.